everybody, my name is Sarah Holmes and I am a math teacher at Johnston County Early College Academy. In today's video, we are reviewing key features of parabolas. So before we get started with an example, let's go over the key features. So you have your domain, your range, your intercepts, which include x and y-intercepts, your axis of symmetry. You're going to either have a maximum value or a minimum value, not both. You have a vertex, intervals of increase, intervals of decrease, positive and negative intervals, and finally end behavior. So let's get started with our first and only example for this video. So for domain, it's your set of all possible inputs. So your job is to tell me what x values are possible to have on this parabola. So when we look here, we see that our parabola extends all the way from negative infinity to positive infinity. That's not because your axis extends that way. It's because as your parabola continues to extend up and up and up in both directions, your x values continue to extend as well. So the way we would write this is negative infinity to positive infinity. Use soft brackets because you can't actually reach negative infinity or positive infinity, so soft brackets tell us that. All right, so range is your set of all possible outputs. So you're telling me what are the possible y values. So in this problem, we need to look, because our parabola opens up, at our minimum value. So over here, we have a point at -1, -18. So we know that our y values are going to go from -18 up. So the way we write that is hard bracket, -18, to positive infinity, soft bracket. So we use the hard bracket for -18 because your y value can be -18. And then it's any number between -18 all the way up to infinity, but soft bracket there because you can't touch infinity. So x-intercepts are the point or points where your parabola crosses the x-axis. So we can see in this parabola there are two x-intercepts. So we see that it crosses over here and over here. Okay? And those points are going to be -2, 0 and +2, 0. They're not always the same number, just the opposite. It just happens to be this case for this parabola. Your y-intercept is the point where your parabola crosses the y-axis. So when we look over here, we see that it crosses at 0, -16. So you just write that as 0, -16. So your axis of symmetry is the vertical line passing through the vertex. So as you can see, I plotted the vertex and I drew a vertical line through there. Sometimes students question whether this would be the equation x equals -1 or y equals -1. Now there's a couple ways that you could figure this out. First of all, the coordinates of your vertex are -1, -18. And so that's a way to know that your x value is -1. And so your equation will be x equals -1. Another option is to think about the points that are on this line, right? You have like -1, 0, -1, -2, -1, 4, -1, 5, -1, 18. What's in common with all of that? They all have a -1 for the x value. So it's essentially saying that anywhere on this line, your x value is -1, which as an equation is x equals -1. So with this parabola, because it opens up, we're going to have a minimum value. Remember, you either have a maximum value or a minimum value, not both. So that's either your highest or your lowest y value of the parabola. So when you look at your vertex, we know that the y value is -18. So in this case, your min value is y equals -18. Don't forget to put that y equals for your min value or your max value, depending on the problem. So your vertex, we've already talked about it. It's very useful for identifying other key features, but remember that it's the turning point of your parabola. It's your maximum or your minimum. Okay? And so in this case, your vertex is -1, -18. So intervals of increase and decrease. Your interval of increase is the interval where your y values are increasing, and the way you write it is to tell between what two x values are the y values increasing. So the vertex is going to be a very helpful key feature to help you determine the interval in this case. So here we're going to go down to our -1, -18. Right there, -1, -18. Because we're curious between what two x values that's occurring at, we care about the -1. And so when you read your graph from left to right, you see that your y values are decreasing, and then they change direction and start increasing. So over here, we see our interval of increase, and that's from -1 to positive infinity. Do not include the -1 because your y values are changing direction. At -1, they are not increasing, they're just changing direction. Okay, so that's your interval of increase. Similar to intervals of increase, intervals of decrease show between what two x values your y values are decreasing. So again, we can use your vertex, the x value of your vertex, to identify this. Make sure you read from left to right, and we can see that our y values are decreasing all the way up until here. Okay, so that's going from negative infinity to -1 are where our y values are decreasing. You can't include the vertex value because that's the turning point, so it's not increasing or decreasing at that point, it's changing direction, hence the soft bracket. So for positive intervals, that describes all places on the parabola where your y values are positive. So those are going to occur above the x-axis because your x-axis is the equation x equals 0. And so anything above the x-axis is positive. And so we can use the x-intercepts to help us determine our intervals. Okay? So I'm going to just circle or box in here. We have two different positive intervals. Okay, so we need to write that using a union to join those two sets together. So we are having a positive interval from negative infinity to -2 or from 2 to infinity. You cannot include the -2 or the 2 with a hard bracket because when x is -2, y is 0. When x is +2, y is 0. And 0 is not a positive number, so it is not included in this interval. So your negative interval is the interval where y values are negative. In this case, we just have 1, and that's anywhere below the x-axis that our parabola shows up, right? And so in this case, that's from -2 to 2, both with soft brackets, because again, if x is -2 or x is 2, the y value is 0, and 0 is not a positive number, so we're going to use those soft brackets for here. Your end behavior, your final key feature, describes what's happening at the ends of your graphs. What behavior is going on here? And so we're going to start with the left end of our graph. So as x goes to the left, y is going up. Okay, but we have to write that as a mathematician would. So as x is going to the left, your x values are approaching negative infinity, and your y values are approaching positive infinity, right? So as x keeps going to the left, your y's keep going up. So that's one end. Now we need to talk about this end. So as x goes to the right, it's approaching positive infinity. And as x is approaching infinity, your y's are going up to positive infinity. Okay, and that's your end behavior. Notice how the x's are approaching negative infinity and positive infinity, and that relates back to your domain of negative infinity to infinity. And notice how your y's are both approaching infinity. That gives us that symmetry that quadratics are known for. Your y's should be approaching the same number for quadratics, unless it's like a special real-life context that has some type of restricted domain. So that concludes the key features review. Remember that your key features include domain, range, both x and y-intercepts, the axis of symmetry, a maximum or minimum value, your vertex, your intervals of increase and decrease, your positive and negative intervals, and end behavior. Make sure that you are familiar with how to find the key features individually and how they relate to each other. Thank you for watching.
Thanks for watching. Check out my other videos to keep on learning math.